Alright, welcome back again to this tutorial. In this video, we're going to talk about the Jacobi method for solving system of linear equations. So this is one of the method or the iterative method for solving a system of linear equations, right? So we have the Jacobi method, the Gauss-Seidel method, and we also have the successive overrealization method. Right, of which in this video we are going to talk about the Jacobi method. Let's say we have a system of linear equations a11x plus a12x2 plus a13x3 equal to b1. Also a21x1 plus a22x2 plus a23x3 equal to b2. Then a31x1 plus a32x2 plus a33x3 equal to what? b3. Right. So this is a system of linear equations, and we are going to make use of the iterative method for solving this one. And one of the methods that we are going to talk about is the Jacobi method that I mentioned earlier. So this is our focus for today. So let's say the matrix from this system of linear equation can be a11, a12, a13, and then a21, a22, a23. We have a31, a32, a33. Then the other side can be b1, b2, b3. Right. So let's continue using the Jacobi method. So Jacobi method, what we do is in each equation we are going to make, so the first one we are going to make x1 the subject, the second one we are going to make s2 the subject, the third one we are going to make s3 the subject. So let's see. So in this case we have x1. Now we have x1 exponent k equal to b1 minus, we have a12x2 minus a13x3, all divided by what? The coefficient of x1, which is what? A11. Now from here we have k minus 1, k minus 1. Right. So now this k here that we are using here is going to be k will be equal to values 1, 2, going in that order. So when k is 1, you have the x2 exponent 1 minus 1, which is going to be s2 exponent what? The 0 here. So that's how it is being done. Now the next one, we have our x2 exponent k will be equal to b2 minus a21 x1 exponent what? K minus 1, then minus a23 x3 exponent what? K minus 1, all divided by what? The coefficient of x2, which is what? a22. Right. Then the next one will be x3 exponent k equal to, we have b3 minus a31 x1 exponent k minus 1, k minus 1, k minus 1, then minus a 3 to s2 exponent k minus 1, all divided by the coefficient of x3, which is what? A3, 3. Right. So this is an iterative method for solving system of linear equations. So you see that when our k is 1, we substitute the values, then we get our answer straight from here. Then as we move on, we keep on increasing our k. So when it's 1, we move on, we do the first one for x1, x2, x3. When it's 2, we do for x x1, x2, x3. So as we move on, we keep on getting different values. We're getting values separately, right? So this is basically the idea behind the Jacobi method. The Jacobi method. So let's say you are given a system of linear equations. Let's have an example from from the next video that we are going to talk about, right? So the next video will be examples on the Jacobi method, right? Thank you for watching.